Well, hello and welcome to this exercise on transformation metrics. Um, I think the title is actually a giveaway, but you won't have that in an exam anyway. Now, what I've done here is to paraphrase the actual question itself, but the difficulty is still the same. What's happened here is that we have a transformation from an object 1 to image 2 to image 3 to image 4. And we are asked to say what type of transformation they are and to confirm our finding using metrics. Now, firstly, it's not translation. It's not translation because the area for the object is different from the area of the image. Now, still with area, the ratio of the area of the image to the area of the object is 3 to 1. Again, can you confirm that yourself? Because that's 2 times 2 is 4 divided 4 by 2, you get 2. And 6 times 2 is 12, divided by 2 you get 6. 6 divided by 2 is 3 to 1. Right. Now the other thing is that the y-coordinates for a given point in the object is same as the y-coordinate for the equivalent point on the image. Yes? So for C, it's same as for C1, and for B, the y-coordinate is same for B1. And one more thing. The distance from the y-axis to C prime, or any other point you want to choose, so to C prime is 6, and the distance from the y-axis to C is 2. Again, there's a ratio of this displacement of 3 to 1 there. So it then seems to me that the transformation from 1 to 2 is by stretch parallel to the x-axis, with the y-axis being the invariant line, and hopefully a stretch factor of 3. Now, if that's the case, in our identity matrix, if we replace the 1 there with a 3, and then multiply this identity with this transformation matrix by the respective coordinates for the object, and because if we're right, if this is stretched by, if this is transformation by stretch parallel to the x-axis with the y-axis being the invariant line, then there should be no difference between the y-coordinates of the object and the y-coordinates of the image. And that's what we've got there. Can you check and make sure that that's okay for you? Because just for the first one, 0 times 0 times 2 is 0, 1 times 5 is 5, 5 plus 0 will give me 5. And this will apply for this 2 here as well. Now the value of the x coordinates will change. 3 times 2 is 6, 6 plus 0 times 5 is 6 plus 0, which is 6. And 3 times 4 is 12, 0 times 3 is 0, 12 plus 0 is 12, and so on. So now the A prime is 6, 5, and we got 6, 5 there. And the B prime is 12, 3, and we got 12, 3 there. And C prime is 6, 3, and we got 6, 3 there. So we're right. So for 1 to 2 is transformation by stretch with a stretch factor of 3 parallel to the x-axis, and the invariant line is the y-axis. Now similarly, the same argument applies from 1 to 2. It cannot be by translation because the areas are different. Now the ratio of the areas again is 3 to 1, and the distance from the x-axis to C prime and the x-axis to C, the ratio of the distances will be again 3 to 1. So once again, it seems to me that this is transformation parallel to the y-axis with the x-axis being the invariant line. Now, if that's the case, then we expect that the x-coordinates will not change. So, and if the stretch factor is 3, we then replace the 1 in our identity matrix with 3 there. And as you can see, the x-coordinates for the image are the same for the s-coordinates for the object, 2, 4, 2. But the y-coordinates will change. So we're going from 533 to 1599. Can you check that for yourself? Because 0 times 2 is 0, 3 times 5 is 15, 15 plus 0 will give me 15 here. 0 times 4 is 0, 3 times 3 is 9, 9 plus 0 is 9, and 0 times 2 is 0, 3 times 3 is 9, 9 plus 0 is 9. So let's confirm that. We've got 215 for A, 215 for A is there. Sorry about the movement, sorry about this movement here. And 49 for B prime, 49 for B prime is right. 29 for C prime, 29 for C prime. So all right, that's okay, that's checked. Now, for transformation from 1 to 4, what we've got is on the y-axis we've got 6 there compared to 2 there, so there's a 3-to-1 ratio there, linear. And from C to A, from C to A, C prime to C, A prime, again we've got 6 divided by 2, 3. So it says again there is a linear scale factor there of 3. So we've got 3 and then 3 there. So it seems to me the linear scale factor is 3. So we expect the area there to be 9 times that of the area there. And that is true. Now furthermore, it can also check that this is an enlargement with scale factor of 3, and the center of enlargement is going to be 0, 0. Because if you draw a line from there, if you draw a line from C prime to C, that will come out as 0, and similarly a line from B prime through B, we end up at 0. But to confirm that using matrix, if this is a scale factor of 3 in the x direction, we replace our 1, 0 by 3 there. The same as in the y direction, so we replace our 0, 1 with 3 there. Now notice here that the x coordinates are the same as the x coordinates in the when object 1 was transformed to object 2 by stretch parallel to the x-axis. Similarly, the y coordinates will be the same as the y coordinates for when we had transformation by stretch parallel to the y-axis. So in effect, 1 to 4 is an enlargement with scale factor of 3, center of enlargement at 0, 0. Now I've got something different for in the next slide. I hope you watch that as well. Right, now this slide is slightly different from the previous slide. Now what we've got here is this objects here being transformed to this image here, and this is a combination of stretch parallel to the x-axis with a stretch factor of 3, because I want 3, 4, 5, 6, 6 by 2, divide 6 by 2, get 3. This is a combination of stretch parallel to the x-axis with the y-axis being the invariant line, and a stretch parallel to the y-axis with a stretch factor of 2 and the x-axis being the invariant line. So that's what we got there. So these two triangles are not similar. So really we cannot call this an enlargement in the sense that we know it. But it's certainly enlarged. The ratio of the area scale factor, if you like, the area scale factor is 6 to 1, 6. And usually for enlargement, as we know it, if we take the square root of the area scale factor, that should give us a linear scale factor. And then if you then multiply any part of the dimension by linear scale factor, you go back to what you had for your image. Now the square root of 6 is about 2.2, they're about 2.3, 2.2 something, 2.4 I think. And now if you multiply from C to B by 2.4, you don't get 6. Nor do you get 6 if you multiply C to A 2 by 2.4. So that won't give you what we require. So in effect, this is not an enlargement in the sense we know it, because the square root of the area factor does not give us the linear scale factor. Now what you might have to try and do is perhaps if you can copy this down yourself and then try and see if you can find a center of enlargement and let me know. Anyway, what's happened there is that we have a stretch factor parallel to the x-axis with stretch factor of 3. We replace our 1 there by 3, and stretch factor of 2 parallel to the y-axis of 2 there. Right, so we replace 0, 1 by 0, 2. And when you multiply out, we have this new set of coordinates. Now, can you check that that's true? All right. And I hope that makes some sense. And thank you for watching. And I see you again sometime. Bye-bye.